Hey everyone, let's pick up where we left off. So we found these first three factors by graphing. We saw that when we graphed, we got the zeros of -2, +1, and +2. And so that gave us the factors x plus 2, x minus 1, and x minus 2. So those have to be our three factors. And then we're going to be multiplied by some other polynomial over here because we have to end up getting a fifth degree polynomial. So there must be two more factors out here that we're going to get our fifth degree. And they're going to be complex. We're going to have complex zeros because if they were real, we would have seen them on the graph. So the way I like to think about this is as if we had a number, like 210. I used this in my last video about fundamental theorem. If 210 is equal to 2 times 3 times some number, there are a couple of ways I can get that number. One way is I can say, okay, 2 times 3 is 6. So then I can say that question mark is going to be 210 over 6. So I can multiply them together, then divide. It'll give me the question mark. The other way I can do it is I could divide by 1 at a time. So I could do 210 over 2. So dividing by 2 gets rid of the 2, but it leaves the 3 in the question mark. So that's 105 is 3 times the question mark. And then divide by 3, which would give me 35 is equal to the question mark. So then I divide by 3 there. And both ways get me the same answer. If you divide 210 by 6, that gives you 35. So in this case, I could multiply all three of these things together. It would give me a cubic. Then I could do long division. So I could do this big P of x divided by that cubic, and it would give me the question mark. But that would take quite a while. So we're not going to do that. What we're going to do is use this second method where we divide by the numbers one at a time. So we're going to divide by the factors one at a time. So we'll start with P of x over x plus 2. And then after we do that division, we can use synthetic there because it's linear. After we do that division, then we'll divide by x minus 1, and then we'll divide by x minus 2. So I'm going to erase these just to give myself a little bit more space. And we'll do some synthetic division. So the first thing I'm going to do is divide by x plus 2, which means -2 goes into my box. List out my coefficients. We got 1, looks like a -1, -3, +3, -4, and +4. Draw a line down here. 1 comes down, times -2 is -2. Add those up. That's -3 times -2 is +6. And -3 make +3. Times -2 is -6. And 3 are -3. Times -2 is +6. And -4 make +2. Times -2 is -4. And that gives us our remainder of 0. So what I have right now is that I did my P of x divided by x plus 2. And it gave me this result. It gave me x to the fourth minus 3x cubed plus 3x squared minus 3x plus 2. So what this is equal to, so we divided out the x plus 2. That's gone. So this is still equal to x minus 1 times x minus 2 times our question mark. So now we're going to divide by x minus 1, except now I only have to take this quartic and divide by x minus 1. The great thing about this is that I have all of these coefficients right here. So I can just plug 1 into my box, draw a line, and now we go off to the races. So let's take down the 1. Times 1 is 1, and -3 are -2. Times 1 is -2, and 3 is 1. Times 1 is 1, and -3 are -2. Times 1 is -2, which once again gives me a remainder of 0, which makes sense because this is a factor. So I just did our new number, our new polynomial here. I took it and divided by x minus 1. And maybe I shouldn't write P of x here, but I'm dividing the polynomial by each of the factors. So we're going to end up with our resultant quadratic over here. So at this point, I have x cubed minus 2x squared plus x minus 2 is equal to, so I've gotten rid of the x minus 1 now. So I got rid of x plus 2 at the beginning, x minus 1's gone now. So now I just am left with the x minus 2 times our question mark. So I'm going to put 2 into the box. And once again, I have all my coefficients right here, so I don't have to make a new box. 1 comes down, times 2 is 2, and -2 are 0. 0 plus 2 is 2, plus 1, 0 times 2 is 0. Fransky. 0 times 2 is 0, plus 1 is 1, times 2 is 2, and -2 are 0. We get that 0 once again. So now what I have shown is that our question mark here is x squared. We have no x term, so just x squared plus 1. So my complete factorization is P of x is equal to x to the fifth minus x to the fourth. Oh, excuse me. What am I doing? I want the factors. So it's x plus 2 times x minus 1 times x minus 2. I'm just taking these from our graph. And now we have this x squared plus 1. And as we said, this should be factorable into complex numbers. And x squared plus 1 factors into x plus I and x minus I. So now I have my complete factorization. X plus 2, x minus 1, x minus 2. Do as I say, not as I do. And then we have the x plus I and the x minus I. So we have our entire factorization. The last two zeros were I and negative I. That's pretty bad. All right. Let's try one more problem here. So this time we're given a quartic, and this time we're given a complex root. So this problem is a little bit different because before we were given real roots, and then we used division to find the complex ones. This time they're giving us a complex root. So let's see what we can do with it. So in terms of our zeros, right now we know that 2 minus 3i is a 0. So then one of the factors is going to be x minus, in parentheses here, 2 minus 3i. So the conjugate zeros theorem tells us that if 2 minus 3i is a root, then 2 plus 3i also has to be a root. So that means that x minus 2 plus 3i is a 0. So right now we have that p of x is equal to our two factors here, x minus 2 minus 3i times x minus 2 plus 3i. And then there's some question mark here. Should be two more factors out here that we can factor in and multiply to get our polynomial. And we want to be able to find them. So what we have to do is divide p of x by each of these linear factors. So in this case, we could do synthetic division. We could divide by each factor separately, and we'll do that on the next slide. But when you have these complex roots, it's almost easier to multiply them together, get some real coefficients, and then do the long division. There are equal opportunities in each case to make mistakes, so let's try this one by multiplying these together first. So we could do that on a calculator. We could do an expand with this and see what we get. But we'll do it the old-fashioned way here, and we'll make a box. So I'm going to make a box here. Hopefully it's big enough. And here we have x, and then we have negative 2 minus 3i. And then here we have x and a negative 2 plus 3i. So x times x is x squared. X times negative 2 minus 3i. Looks like I'm going to have a negative 2x there. And then I have a negative times a negative here, which makes a positive 3xi. Down here, negative 2x again. And then here I'll have a negative 3xi. So you can see that those xi's are actually going to cancel out. So I have positive 3xi here, I have negative 3xi here. They just go away, which is nice. And then down here I'll have a negative times a negative, which will make a positive. And these are conjugates of each other. So remember that when we have conjugates of each other, it's just the first thing squared plus the second thing squared. So that's going to be 4, let's see, I'll write down here. So it's going to be 4 plus 9, which is just 13. So the result of all this looks like it's going to be x squared minus 4x, because we have negative 2x here, and then plus 13. So that's what the product of these two things is right here. These two factors multiplied together give us x squared minus 4x plus 13. So at this stage, I have that p of x is equal to x minus 2 minus, sorry, the whole point here was that we multiplied those things together. So it's x squared minus 4x plus 13 minus 4x plus 13. And then that's multiplied by our question mark. Because what we did was we multiplied these two together, got this x squared plus minus 4x plus 13, and we're still multiplied by the question mark. So if we do long division by this quadratic, we'll be able to get our question mark. We'll do that on the next slide here. So x squared minus 4x plus 13 is what we got there. So it's this guy multiplied by some question mark is our p of x. So we're going to do long division by the x squared minus 4x plus 13 to find that question mark. So let's put x squared minus 4x plus 13 into x to the fourth minus 4x cubed plus 12x squared plus 4x minus 13. X squared into x to the fourth, we need x squared to multiply there. Gives us x to the fourth. X squared times negative 4x is negative 4x cubed. Oh, that's nice. It just cancels right out right away. X squared times 13 is a plus 13x squared. So remember, we have to subtract that. So the x to the fourths go away, the negative 4x cubes go away. It looks like 12x squared minus 13x squared is going to give us a negative x squared. So now, to get that negative x squared to cancel out, we're going to need a negative 1 up here, because negative 1 times x squared will give me a negative x squared. Should have brought the plus 4x and the minus 13 down here for the ride. So then negative 1 times negative 4x is a positive 4x, and negative 1 times 13 gives us a positive 13. No, negative 13, excuse me. Let's say that should cancel out. Subtract that whole thing, and everything cancels out. We're left with a remainder of 0. So now we know that question mark is x squared minus 1. So we have p of x equal to, I'm going to go back to my imaginary roots here because I want the whole thing factored out. So it's x minus 2 minus 3i. So it's x minus 2 minus 3i times x minus 2 plus 3i. And then our new factor here is x squared minus 1. Well, that's actually really handy because x squared minus 1 is a difference of squares, so we can just factor that. So this is x minus 2 minus 3i times x minus 2 plus 3i times x plus 1 times x minus 1. And that's all there is to it. So we have our complete factorization. So I'm going to stop this video here because I think that's the easiest way to do that problem. If you really like synthetic division, what I'm going to do in the next video is show how we could synthetically divide using these imaginary numbers. So if you'd like to join me for that video, I will see you soon.